Hi, I'm Scott Knockleby. In this video, we're going to look at fixed and Euler angles. By the end of this video, you should be able to understand what are fixed angles and Euler angles and how they are used to represent orientation. So in a previous video, we saw how we can represent orientation using our rotation matrix. Okay, and there's different ways we can actually generate our rotation matrices and describe orientation. In robotics, two of the most common ways we can represent orientation are using fixed angles and Euler angles. So let's look first at fixed angles. So we're going to look at an example to illustrate the idea. So we're going to look at what are x, y, z fixed angles. All right, and we could do other combinations. We could do z, y, x, and so on. But let's look at an example with x, y, z fixed angles. So in this case, we first start with frame B, coincident with frame A. So by this coincident, we mean the origins are the same point and the x, y, and z axes are all aligned with each other in the two frames. We're then going to rotate our frame B about our XA axis by angle gamma. All right, so we're doing a rotation about the XA axis by gamma. All right, and that will change the orientation of frame B as such. Okay. We're then going to rotate frame B now about our YA axis. So here by amount beta. So this is a rotation about the YA by beta. And this is where I get fixed angles its name from. We're always rotating about this fixed frame of reference, in this case frame A. And then lastly, we're going to rotate frame B about the ZA axis by alpha. All right, and you see that in this figure here. We're rotating frame B now about our fixed ZA axis. So we want to be able to get our rotation matrix. Okay, so we want R that describes frame B with respect to frame A. All right, and so for fixed angles, what you have to do is you have to pre-multiply. All right, so you do it in the pre-multiply, so the sort of the opposite order of how they were done. So we start with our RZ axis rotation, which was by the amount alpha. Then we had our rotation about our Y axis by beta. And then lastly, we have our rotation about our X axis by gamma. All right, so you have to pre-multiply when you have fixed angles. So anytime you have fixed angles, you're going to pre-multiply them. So that differs from Euler angles. So let's look at an example of Euler angles. In this case, we're going to look at Z, Y, X Euler angles. But just like for fixed angles, we can have different combinations. We could have X, Y, Z Euler angles and others as well. So in Euler angles, again, we start like we did for fixed angles. We have the frame B coincident with frame A. And now we're first going to rotate frame B about the ZB axis, which in this case is equivalent to ZA because those two frames are initially coincidents, by an angle alpha. All right, so we're rotating our B frame about our ZB axis by alpha, and this is going to define a new frame, which we're going to know B prime. We're now going to rotate the B prime frame about our new y-axis B prime. All right, so this is our new y-axis. So now we're going to rotate about it by the amount beta. And this is going to define a new frame B double prime. And then lastly, we're going to rotate that frame B double prime about our XB double prime axis by some angle gamma in this case to define our final frame, which is B triple prime. All right, and so here we're rotating about our B double prime axis by gamma to get our new frame B triple prime. So for Euler angles, we post multiply. So we write our rotations out in the order that they appear. All right, so we did a rotation about Z first, by alpha. We did a rotation about the y-axis by beta. And then lastly, we did a rotation about the x-axis by gamma. All right, and so in this case, we post multiply. So for fixed and Euler angles, there are actually 12 different permutations of fixed angles and 12 different permutations of Euler angles. Appendix B of Introduction to Robotics and Mechanics and Control, 4th edition, lists them all if you want to see them. So you can check out that reference.